Hi, and welcome back to our discussion on fuels. So this time around we're going to swap from fossil fuels and that idea of carbon being trapped in that fuel from organisms that died millions of years ago to biofuels. So in this case we're talking about anything that is derived from plants or living materials in a more recent time frame. So biochemical fuels or biofuels are derived from plant materials. This is an important idea because this means that the carbon has been recently trapped into these. Okay, if you think about it, plants take in carbon dioxide and convert this into glucose during photosynthesis. That means that they're taking in carbon dioxide from the atmosphere and trapping it into the plant itself. Okay, so the materials that we talk about for this are largely things like grains. So maize, which is corn, wheat, barley, or sorghum, which is a grain type plant, sugarcane as well, vegetable waste or vegetable oils. And if you've driven around Victoria at different times of the year, you will have seen the fields filled with bright yellow flowers, and that's actually canola for canola oil. It's something that we grow a lot of in Victoria. So from these grain stocks and plants, we of course don't just use this in our cars or anything like this, but what we tend to do is make ethanol or biodiesel from these, and those compounds, once we make them into ethanol or biodiesel, are known as biofuels. These can be used alone, independently, or blended with fossil fuels such as petrol or diesel, and you will have seen things advertised like E10, which has 10% ethanol mixed in with the petroleum for sale. So these fuels are considered carbon neutral because the production harnesses the natural photosynthesis process. Okay, so as I said before, carbon dioxide is reacted with water in the process of photosynthesis using sunlight. This then causes glucose to be made, which is used by the plant and gives off oxygen gas. If you've done bio, you probably know this formula. If you don't, this is one to be put into your notes that you need to memorize. The use of bioethanol is different per region. A lot of that tends to be dependent on the stocks, the feedstocks that they can get hold of. Brazil tends to make a lot of ethanol, bioethanol, because of large sugarcane production. Then you have the US tends to make a lot from different grains and things like that. We have a mixture of things from oils, vegetable oils, as well as sugarcane. So our biofuels that we're going to talk about include bioethanol, which we produce from sugarcane, maize, wheat, biodiesel, of which we need an oil to start from. Okay, so these will be vegetable oils, palm oil, rapeseed oil, or sunflower oil. So any of the oils that you may be familiar with for cooking or things like that, we can actually use to produce biodiesel from. Biogas, which we can get from fermentation of different crops, and then biomass to liquid, which we get from wood, which we don't cover within this course. So these are the three main ones that we need to know in detail and that we'll talk about. So bioethanol, okay, is produced in the same way that we produce ethanol for just about anything. This is primarily breaking down starches and sugars, which we will study more in Unit 4, but the carbohydrate parts of the plants are converted into glucose using yeast enzymes, so catalase. This is done in fermentation in the same way that we get alcohol being produced or ethanol being produced through the fermentation of grapes or malt for the production of beer or wine. This is the same process, except it's not stopped early on. The process has continued to go for the production of a large high concentration of ethanol. So we take glucose, C6H12O6, aqueous, because we're talking about it being in a living system. It is exposed to enzymes, primarily yeast. enzymes that are found in the microorganisms known as yeast, and it produces 2 ethanol and 2 carbon dioxide. This is an interesting one because when we talk about carbon neutral, we can see that we take carbon dioxide in to the plants, we produce ethanol, but we're going to produce carbon dioxide during the fermentation process. And then when we combust it, of course, we give out carbon dioxide as well. So this tends to be a less carbon neutral fuel than the others due to the production of CO2 during the fermentation process. Okay, a thing to note here is that this is an anaerobic process, the production of ethanol by fermentation, so oxygen is excluded from this process. Okay, we can use ethanol as a fuel independently, and we can also blend it with petroleum. This gives you an idea of the large-scale production of ethanol. So we can see here that grains, large amounts of grains, are produced into a feed hopper, and then they're added and formed a slurry. Okay, it's crushed and milled to increase surface area. Then it's heated. Okay, it's heated to 85 to 105 degrees. We don't want it to be too hot for the enzymes, otherwise we'll kill them. They then hydrolyze the starch, and hydrolysis is the opposite of condensation. So where we get a water molecule out from condensation, hydrolysis puts the water molecule back in, and in this case it hydrolyzes an ether bond, which produces 2 alcohols. This is then cooled, and throughout the process it goes through different hoppers and different heat exchangers, and then it's left to ferment in a fermentation chamber. One of the things that can be noted here that we deal with the renewability aspect of CO2 into the atmosphere is that the carbon dioxide can be captured and used for food processes. So we can use this in carbonated drinks. Okay, so they put it into soda stream canisters, things like that, or for the large-scale production of soft drinks and carbonated drinks. The solid waste then, because you can imagine there is a large amount of solid bits of grain and cellulose and stuff like that, is often then used as a feedstock for animals. So this process of recycling the carbon dioxide that is produced into other uses and using the waste brings back up that idea of renewability and sustainability. Okay, so we get ethanol as a product, but the waste products are able to be used in other areas as well. So the next one that we're going to look at is biodiesel. Biodiesel is a mix of esters. Okay, so you remember that an ester is a R C double bond O R, which is made from the condensation of an alcohol and a carboxylic acid. These are produced from vegetable oil and a small alcohol, often methanol, but can be used with ethanol as well. The vegetable oil sources we use tend to be ones that are high in oils, so these we tend to use for cooking oils as well. So it can be soybeans, canola oil, palm oil, which has a lot of associated environmental problems in terms of habitat destruction. We can also use recycled vegetable oils, so things that have been used to cook fish and chips, so things like your oil reserves from the calf and things like that, they can be used. We can also use animal fats, but these have a lower melting point and boiling point, so we'll have flow-on effects and problems with that. This is generally used as a mixture with fuel again. So as we said, E10 was ethanol. Things like B5, B10, and B100 give the percentage of biodiesel mixture in a fuel. These are biodegradable, i.e. they will break down in our environment. They're non-toxic and they produce fewer emissions because there's no SO2 or NO2. Same with ethanol. When ethanol is burnt, we don't see the production of SO2 or NO2 because there isn't residual sulfur or nitrogen in the fuel itself. So if we look at the biodiesel cycle, again, we are getting oil from crops. So the carbon is being locked in from the atmosphere from the carbon dioxide. Okay, so it's going to be a carbon neutral process. The point where carbon neutral can fall down is, of course, transportation and energy used into the process. These are not carbon neutral, but the production, the fuel itself in terms of the carbon that goes into the fuel, we consider to be carbon neutral. Okay, so we take the vegetable oils, we then esterify them using a product, and we get glycerol from this as a byproduct and biodiesel. So in order to understand this process, we need to understand why fats and oils will work like this. So fats and oils are known as triglycerides, tri being 3, okay? And this is their structure here. Glycerol, which you will find in your data book. Okay, the actual structure of glycerol, which has 3 carbons and 3 hydroxyls. Okay, this is the structure of glycerol. We take glycerol, it is subjected to a esterification reaction with fatty acids. Okay, so this is the structure of your triglyceride. When we talk about triglycerides, so we're talking about fats and oils, and they all have this structure. We have 3 fatty acid arms. Okay, so we have 3 fatty acid components which form an ester and linked to a glycerol backbone. Okay, when we hydrolyze these, we release the carboxylic acid. Okay, and the glycerol. So let's have a look at that process. When we want to make the biodiesel, we first need to take the triglyceride, so this one is palm oil. It is hydrolyzed in situ, and in situ means within the flask and during the reaction. So this is usually base catalyzed. So we will add a strong base such as sodium hydroxide or potassium hydroxide. That catalyzes, hydrolyzes our ester. We'll break these bonds here. Okay. It will release the glycerol, okay, reforming the hydroxyls. And then if we do this in a solvent of methanol or ensure there's excess methanol in the flask, this will then cause the esterification to form the biodiesel molecule. So the first bit is the esterification of the triglyceride, the hydrolysis of the triglyceride, followed by esterification of the fatty acids to form biodiesel. The last one that we're going to look at is biogas. This is essentially an equal mixture of carbon dioxide and methane. This is a gas that is generated when organic material decays in an anaerobic fashion. This is in the absence of oxygen. So we will get methane and some carbon dioxide being produced from this. It can be used to heat and power homes, so you'll see biogas generators used in Scandinavia and various other places around the world. The waste can be used as rich fertilizer, and it's used extensively in places like China, where you will have large farming or industrial farming scale, where you have a lot of organic waste that is going to decay. Okay, so one of the things that's being looked at different places around the world is actually collecting biogas from landfills. As the waste rots, it will produce methane. This can then be used as a fuel. This could be done in chicken farms, landfills, food processing plants, or anywhere where we're going to have a large amount of organic material produced as waste, and then it's going to break down. So when we get this, it has a mixture of different gases in it, and the one that we're primarily interested in is methane. Some other gases can be produced from this, but captured methane, again, will be, in this case, won't have sulfur or nitrogen. So there's a number of ways that they're looking at capturing biogas. As I said, a lot of large-scale farms and things like that are looking at biogas generators, or where you've got fermentation. This, such as manure, can be captured and then into a biogas generator. As it decomposes, the gas, of course, is going to rise out and can be captured and used for other things. Okay, just at the end here, a couple of questions for us to look at in the way that these might appear in exam questions. So this one here is on biogas, and the question states that biogas can be generated as a byproduct of farming activities. Okay, byproduct is something that is not your intended purpose. Wastewaters often contain sugars such as glucose, which can be converted into methane. Okay, and a simplified reaction sequence is given below. Okay, so we've got fermentation, so we know that this is going to produce CO2 and requires glucose, which we see here. And then the oxidation, so we have the alcohol being converted into the carboxylic acid. Neutralization, so this is an acid, so it's being neutralized by the calcium carbonate. Okay, this is going to give off CO2. If you remember, we have acid plus metal carbonate will produce salt, CO2, and water, and we have a calcium ethanoate salt here. Then bacterial conversion of the salt into methane. Okay, the ratio and volume of methane produced to volume of carbon dioxide produced in the overall process is. So we want to look at methane produced to the volume of carbon dioxide produced. So we want to look at the overall mole ratios. See here, we have 2 methane being produced. We have 1, 2, 4 carbon dioxide being produced in this, and none of it being consumed on the left-hand side. So in this multi-process cycle, overall we're seeing 4 carbon dioxide being produced and 2 methane. When we simplify down this ratio, we're going to have 1:2 overall. And if we have a look, B was in fact the correct answer, and it steps through the process there. With this one, it's just a mole ratio question, looking at our basic stoichiometry and figuring out how many carbon dioxide are being produced in respect to the methane. Okay, last little bit. Again, this one's going a bit long, so let's wrap it up. With biofuels, we want to be able to compare them in terms of good and bad, as we're using these as a replacement for fossil fuels. If we think about it, these can be considered close to carbon neutral. Okay, so that means that they're not going to contribute to the enhanced greenhouse effect and climate change. Because the carbon that is given off during the burning of the fuel is considered to be equal to that consumed in photosynthesis during the life of the plant, we can consider this carbon neutral. It's not exact, of course, because there will be carbon dioxide giving off in the production and the transport, but it is considered more carbon neutral than fossil fuels. We can produce biofuels from waste from general societal living and farming. So we can use up waste from industrial scale food production, landfills and things like that for their production. It uses resources that are available in Australia, providing employment and minimising importation costs of this economic flow on. There is a downside to this, however. The use of plant materials for the production of fuel requires land use, and this means that land that could otherwise be used for food crops is going to be used for the production of fuel. This also means that they're subject to drought and floods, which can interrupt production. Some energy is still used in their production because we have to have multiple steps to convert them into a usable fuel. And unfortunately, biodiesel, bioethanol, and biogas do not provide the same amount of energy per gram as what we see from fossil fuels. They have a lower energy density, which tends to mean we need to use more of them and transport more of them to get the same energy use in day-to-day life. So this brings us to the question of whether or not these are sustainable. Okay, so in terms of biodiesel and bioethanol, they are definitely renewable. We can produce these in a faster rate than what we use them up, okay, due to the life cycle of the plants that are used. However, there is a question on sustainability with regards to land usage and climate change in terms of drought, water, and things like this. This is not something that will necessarily be sustainable on the long term. And when you're talking about those compare and contrast questions, again, there is not always a 100% certainty on anything that we're talking about. So they have both renewable and sustainable sides, but also downsides. So if we have a look at this question here, which one of the following statements best defines a renewable energy source? Remembering that this is something that can be replaced at the same rate it is consumed, we're going to go through. Option A says an energy resource that will not be consumed within our lifetime. This is not correct because this is actually our definition of sustainable. An energy resource that does not produce greenhouse gases when consumed. Again, this is not necessarily true. An energy resource derived from plants that are grown for the production of liquid fuels. This one is looking good because we do tend to look at this, but this doesn't discuss all renewable fuel options because we also have solar and wind, which are not plant-based. And an energy resource that can be replaced by natural processes within a relatively short time. This one covers everything correctly. It's not talking about things that could be untrue for other parts of renewable. So it's replaced by natural processes. This covers our solar, wind, and tidal as well as our plant-based biofuels. So D is the best option for this question. If we have a look, it is the right answer, and you can see that these are questions that are answered generally well by students across the state. I'll leave you to do this question yourself and go through the answers, and that finishes up our look at biodiesel, and I'll see you in class.